Hello, this is the project for development environments. We are students of electronic engineering and telecommunications. So for this project, we will do a deep learning algorithm for image recognition. For this, we used a Drive. I don't know if you know Drive, but it's a so powerful tool for this kind of projects. It's important because, for example, in my computer, I don't have a GPU, is a graphic process unity. So it's so hard to process this kind of things, and it's better to use things like virtual machines for this. So we can see here we have a GPU, so it's better for processing. This is like a virtual machine, but we can use it for free. So the first thing we do is to install our libraries that we will need. For this we will use TensorFlow and keras. Apart from TensorFlow, we are using TensorFlow 2.0 right now. It's just available for Google virtual machines. So the first thing we need to do is to download the data. This data is in a link. It's part of the TensorFlow databases. I will leave the databases on the description if you want to see the different kind of databases that we can offer. We will extract this and save the path where the image will be loaded. So we need to analyze what we have on these files. So we can see there's cats and dogs pictures, and we have two different image. We have image for training and image for validation. So right now we are loading this data, and we will see we have to rescale these pictures. This is to making the code always most efficient. We set a height and a width for this image, and we prepare the data. So for this preparation, we set different things. I will leave the my GitHub repository on the description. You can see all my comments on my code there, and we can see a little bit example of what we can find on the different files. So we can do a different kind of things for this training. It's important to make some change at our training pictures, because maybe we wouldn't want to try a perfect neural network where all the pictures are like the same, of a perfect cat showing his face. So we need to do some kind of things like make zoom or flip a little bit our image. It's important because this will make a better trained convolutional neural network. So there are some kind of examples, like these cats that are flipped 45 degrees. We can make zoom too. Wait, I will show you. This is an example of what zoom does, but those examples are for separated, so we will not do this all together to have a better data set to training our neural network. So there is our example. You can see we have the rescale, the rotation, the different zoom, and for validation data we're not gonna do nothing. So we can start training our neural network. It's important to know that we will use a convolutional neural network because it's better to works with image, because an image is made of pixels, and each pixel is a kind of matrix, so it's hard to process for the computer. So we have to do some kind of things like the convolution and max pooling to make it slow, less heavy for our computer for processing. So we have different filters and different filters for convolution and different max pooling process, and we can see with this model summary. Model env is the name of my neural network, and with the summary we can see how the neural network is. So we can see the different layers. There is a convolutional layer, max pooling, dropout. Dropout is so important because we need to turn off some of the neural net of the neurons when we are processing, and then our neural network will not learn from memory the paths, and will take different paths. So it's better for a good training. And right now we will see how to training is. We need to define the epoch, and it's important to define. I have defined this before on the code, and we need to define like how many images we will take for each epoch, and the different numbers of back propagations and okay. So it takes some time to load, and right now we can see graphics of how the network has been training, and we can see something so interesting. We have overfit in this example. We can see that the validation data has fallen. It's important this doesn't happen. I have different examples of neural network that I have done for this. So all the examples will be on the descriptions with different data sets, maybe heaviest of load, but using this tool, it's you can try with this. So this is the less heavy for processing, but you can see you have a small data set. And right now we will try to see how this works. So I load this image. It's a cat, and we will pass this cat to the neural network to see if the neural network can recognize it. So we write here cat, and we can see the predict. Well, gato is cat. Sorry, I forgot to leave this in English. I will change this when I update the file. And we can see here this command is important too if you want to save, because for the case of this tool, Google Colab, our virtual machine will restart each sometime. So it's important to save our file, and we can see the structure of neural network and the ways. So you can load this. And for the application we have this example of TensorFlow, where we can try we can load our models from that we have trained on TensorFlow, and we can try these models on a mobile application. So the thing I have here is Android Studio, and with Android Studio we have an application where we take permissions of the camera, and we can load our different models. And this is all. So for this part, I decided to show how the application works. This application is based in one application from TensorFlow. You can search, I think in the description, maybe I will leave the GitHub repository. You can search them there.
and I will show you how this works. So it's the same that I showed you before at Android Studio. You can here click here where it says TensorFlow classify, and you can see maybe if I put this here, here says it's a switch or works with the TV. It is not so precise because this model has a lot of things, but you can load your own model, our objective was to load a model just of animals, the one that I showed you before, but this one is the model that this application brings by default. You can try different models to play, and this is all. Thank you for watching.